Before we move on to our main new topic, I want to talk a little bit about the data structures that we've already covered, dictionaries and maps, which we covered with hash tables, and somewhat related concept of sets. So with the dictionary and map, we had some goals and some operations to support those goals. So one of our goals was to have array-like access. So we have some value that gets associated with some key. Okay, so common operations we had were things like put, that will put a new key and associated value into the dictionary. And again, sometimes in other programming languages, you see this with array-like semantics. So you can kind of think of this as comparable to assignment to a particular index of an array. Of course, one of the important distinctions here is that this key isn't really an index. It's not necessarily a counting number. It's not necessarily used to keep items in a distinct order. So the complement of put is the get operation that returns the value for a given key. And again, it's kind of like looking up or accessing something in an array at a particular position. Also, some implementations use slightly different names for these. So sometimes the concept of find is used rather than get, but it means basically the same thing. It's still a lookup of some information based on a key. Also, there are usually some other miscellaneous operations. So one of the obvious ones is for removing things from our collection, which is usually just referred to as this remove. Okay, so one of the properties here is that the keys must be unique or distinct, at least in all of the implementations we talked about. So that's a common feature of the concept of a map. There are some implementations that are referred to as dictionaries that allow keys to have multiple values, but most programming languages that support the concept of a map or dictionary, it is a unique mapping between a single unique distinct key and an associated value. Okay, let's talk a little bit about sets and their goals and operations. So the goal of a set is to store unique items. So it's still about kind of keeping something distinct. So basically it's kind of like a map where we've thrown away that value part and we don't care about it. It's just kind of all about the keys. So the operations may go by slightly different names, but generally they work in very similar sorts of ways, and the names of the operations are usually descriptive enough to figure out what they mean. So for example, in Java, you may see .add to add a value to a set, or in some implementations outside of Java, you may see .insert. And this is kind of comparable to the put, but again, without the value. Retrieving data is a little bit different. Typically, we're just interested in whether a particular key is in the collection. So oftentimes there's a .contains or .exists that is very similar to the get, but it returns a true or a false value. If we are looking for a particular key, we already know what that key is. There's no point in returning it. Where the get operation, we would provide it with a key and it would return the corresponding value if there was one. Okay, so I wanted to take a quick look at Java's set interface. So we'll look at that now. So the set interface, by the way, in a moment we'll talk about the concept of iterable things. So I just wanted to mention that Java's sets, and in fact all of Java's collections, support this iterable super interface. So over the course of this module, we'll get a little bit of insight into what that means and what that provides. Okay, so let's go ahead and just take a look at the operations. So there's an add operation. It adds the specified element to the collection if it's not already present. And the contains operation, which again returns a Boolean if the collection contains the given item. Oh, by the way, notice that there's this iterator thing down here. Again, we'll come back to the concept of iterable and even talk a little bit about what this iterator thing does. But while I'm here, I wanted to note that it returns an iterator object. This module and the next cover the concept of ordered collections. So basically, the concepts that we'll be covering these next two modules can be used to represent either a map or dictionary or the concept of sets. So really what we're interested in is accessing data using a key. There might be an associated value with it, in which case we'd implement it as a map or a dictionary with the corresponding map or dictionary operations, or we might just be interested in the key itself, in which case we might focus on the set operations. So since they both focus on keys, we'll actually use sets, the simpler of the two, and just kind of ignore the associated value. So we're going to focus primarily on the set operations, but in actual practice, maps and dictionaries are probably a lot more useful than pure sets in a lot of problems. So in actual practice, you're more likely to encounter maps, but we are focusing on how to access data and the impacts of how we store data on our access times. So we'll simplify our work and focus on sets. Okay, one other thing we should talk a little bit about is hash tables have some pretty serious limitations. So some of their weaknesses are related to performance. If you remember, in order to get good performance out of the hash table, we need to have a hash and compression function that spread data out evenly over the hash table, such that typically each bucket has a single item in it. So we have to know something about our data and have an effective hash function in advance to be sure that we're going to get good performance out of hash tables. Not only that, but we have to implement rehashing so our table will grow and ensure that on average each bucket only has a single item in it. And every once in a while, we're going to have to grow the size of the hash table, and that's an order n operation. So every once in a while, a put operation will take a lot of time. On average, they might be constant time, but every once in a while, a single put will cause the table to grow. Now, there are situations where this is undesirable, where you need firmer guarantees than this. There's another downside. It's difficult to provide ordered access of naturally ordered keys. So for example, if we're putting a bunch of English words into a hash table and we want to access those in alphabetical order, that's going to be difficult to do. If we're using integers as our key, maybe student ID numbers, for instance, and we want to traverse through those in a sorted order, it would be difficult to do. It's also difficult to find a minimum or a maximum value. So those are kind of the major concepts that we're going to be adding in this module. Some way of storing data that could be used as in either a map-like or a set-like manner, but will also provide some additional operations like the ability to get a min or max item, or iterating through all the data in some order, ascending order or possibly descending order.